This video shows a worked solution to a problem about position vectors and unit vectors in the context of a practice exam. Question 1 Part A asks us to determine two things. Firstly, the position vector RA, and then the unit vector UA in the direction of RA. First we need to understand the diagram, which gives context to the question. We see a pipe construction which is fixed at B. The origin has been located here, with the x-axis here, the y-axis here, and the z-axis here. The point B lies in the xy plane. These dimensions describe its location relative to the origin. The point A is directly above B. The force F, applied to the free end A, is used in later parts of question 1, so we don't need to worry about it. Now that we know what the situation is, we can move on to answering the question. The position vector RA describes the location of A in relation to the origin. The dimensions on the diagram give us all the information we need to write down RA. This dimension tells us that to get from the origin to A, we must go 250 millimeters in the negative x direction. We must also go 500 millimeters in the positive y direction and 400 millimeters in the positive z direction. The positive x direction is represented by the unit vector I. We want to go 250 millimeters in the direction opposite to I. The positive y direction is represented by the unit vector j. We want to go 500 millimeters in the direction of j. The positive z direction is represented by the unit vector k. We want to go 400 millimeters in the direction of k. Now we didn't write it down at the time, but each of these numbers represents a distance in millimeters. We must remember to write the units down now. If we leave them off, there's no way of knowing what the numbers mean. We now have to find the unit vector UA in the direction of A from the origin. It has the same direction as RA. The formula UA equals RA over the magnitude of RA can be used to determine the unit vector UA. The position vector RA describes the location of A. It contains information about A's direction from the origin and about its distance from the origin. We want to get rid of the distance information so that we're left with information purely about the direction. Now we've just determined that RA is minus 250I plus 500J plus 400K millimeters. We still need to find the length of RA. By Pythagoras, the length of RA equals the square root of minus 250 squared plus 500 squared plus 400 squared, and that equals the square root of 62,500 plus 250,000 plus 160,000, which equals the square root of 472,500. We approximate that to 4 significant figures while we're still working with the information, so the length of RA is about 687.4. Remember that we're talking about length, and this scalar quantity has units which must be included, in this case millimeters. We now have everything we need to use the formula, so it's time to substitute in and do the calculations. We begin with the formula UA equals RA on the length of RA. We know that RA is minus 250I plus 500J plus 400K millimeters, and the length of RA is 687.4 millimeters. Divide minus 250 by 687.4. Divide 500 by 687.4. Divide 400 by 687.4. and divide millimeters by millimeters. The millimeters cancel to leave us with a dimensionless vector quantity. Using our calculator, we see that UA is minus 0.3637i plus 0.7274j plus 0.5819k. Rounding to three significant figures for our answer, we have UA equals minus 0.364i plus 0.727j plus 0.582k.